Let's take a look at an LDR, a light dependent resistor. Here's one here, and as it sits, it's at about 1K, and if you put it into a shadow, it can go up to about 50K. So we're going to use one as a motion detector. And a lot of the cheap props you buy, this happens to be a Halloween prop. It has one right here, and it uses it to detect motion when there's a shadow across it. It'll light the LED. So we use a voltage divider here to bias the transistor, just a common way to do it, and an LED right here. Now we're putting 5 volts across here, so to find this resistance, we just take the 5 volts minus the drop across the LED, which is about 2 volts or so, and we divide that by our 20 milliamps going through the LED, and it comes out to 154 ohms. I had a 220 ohm resistor. I'm using that. And so here's a circuit over here, equivalent circuit. We know what this one is, and we know this is going to be 50K in a shadow, and we want it to turn on when it gets up to about 50K. So we have to find R1. Okay, so this is an equivalent circuit to this one, and if you take these two resistors and put them in parallel, it should come up to this base resistance here. So the equivalent resistance is equal to the base resistance is equal to R1 times R2 divided by R1 plus R2. It's just these two in parallel. So we have to find this one, this 32K. We don't know what that is yet. So we take the base current is going to be equal to the collector current, which is going to be 20 milliamps, divided by the gain, and we're saying that's about 160 beta on that transistor. So if we divide that out, the base current comes out to about 125 microamps. And we just use Ohm's law here, and we divide that into our 5 volts across there, minus the voltage drop across the junction, and we get about 32K. So that's where we came up with a 32K for that. So we know this has got to be 32K to turn on this diode here, or the LED. So we need to find R1. So on this formula up here, we know the RB here, the base resistance. We know R2, or 50K. We don't know R1. So, you know, I did it over here, just basic algebra. You know, whatever you do to one side, you do the other. Multiply both sides by the denominator, and then you subtract 1600 from both sides, and I subtracted 50 from both sides, and then I divided, you know, both sides by 8 minus 18. But an easy way to do it is this formula here. R1 is equal to R2 times RB, the base, divided by R2 minus RB, and that's going to, if you calculate out, it's going to come out to 88K. So this R1 has to be 88K here. Okay, so I'm going to put an 88K resistor up here, and we'll see if this thing can detect a shadow across it there. So here's the unit here. If I turn it on, and it detects it. Now I could lower this one down a little bit. 50K is probably a little bit much for it, but it works. Can't see it with my hands over it, but it does work. I think I might change that to maybe 30K, and then recalculate this this formula here. So anyway, that's a LDR, light dependent resistor. They use them a lot in these cheap props. And thank you.